Hello world, it's NGO engineer. It has been long. Okay, so today we are going to talk about the design of a reinforced concrete beam. In our last video, we have the time to show you how to evaluate the the P ultimate, in other words, of a reinforced concrete beam. So here is the cross section for a given beam. Then we are going to now move to the next phase, that's determine to how to determine the section of the steel or the area of the reinforcement needed for our beam. Okay, so in this first part of the video, I will show you how to actually distinguish, because there are many things to know. You have to, before having the section of the steel reinforcement that you put in your reinforced concrete of your in your reinforced concrete beam, you have to know if it's pivot A, pivot B, or pivot C. Okay, so first of all, in this first part, for the video, as a reminder, to see how to determine the P ultimate, you just have to check on the link above and on the title of the video that I will leave above, so that you can go and see how we actually find the P ultimate. That's the combination of the load, both permanent load and live load at the ultimate limit state. Okay, so first of all, when you have this information, you have the cross section of your beam, that's 20 by 40 centimeter. Then you have the P ultimate given at 320 kilonewton per meter. Okay, then you have the concrete the concrete strain after 28 days, which is 25 megapascal. Then you also have the steel. Okay, the strain of the steel, which is 400 megapascal. That's the elasticity of our steel. Okay, what do? The first thing that you have to do is to find the u ultimate, mu ultimate. Okay, mu ultimate. And how do you get this mu? This mu ultimate is actually equal to the ultimate moment that you have, divide by what? Divide by BD square sigma DC. This is the DC here is the characteristic strain or the design strain of your concrete. Okay, so the first thing you can see that in this equation, we have the ultimate moment and the design strain of our concrete that we don't have. So we will start by looking for the M ultimate. How do we get the M ultimate? The M ultimate will vary in function of our structure. So in case you have a uniform distributed, a rectangular beam with a uniform distributed load, okay, you have here, this is the uniform distributed load. In cure is actually given in kilonewton per meter. Okay, in this scenario, you will simply have here your M ultimate, okay, which is the maximum bending moment, actually equal to what? Is equal to cure L square all over 8. Okay, now when you have this type of scenario where you have a concentrated load applied at the center of your simple supported beam, okay, what do you have? If the load is P, okay, you have the maximum bending moment will be given as M ultimate is equal to PL all over 4. Okay, then now what, when the concentrated load is not applied at the center, okay, when it's not applied at the center of your beam, like you have here A, okay, and here the distance is B. In this case, the load is applied at the center, so you have A here. Okay, so here now you have A and B, so the distance are different, so it's not located, the P here is not located at the center of your beam. So you will simply say that the maximum bending moment M ultimate is equal to PAB all over what? All over L. Okay, L given here being the span of your beam, this L. Okay, so apart from it, you have the case of a cantilever beam with a uniform distributed load. For example, this is the representation of our uniform distributed load, like the case of what? You have the M ultimate here will be given as a cure L square all over 2. Okay, so these are the formula that you need to know in order to be able to find your maximum bending moment, which will be used as your M ultimate in these steps. Okay, so since here we'll study but the case of a uniform distributed load, a simple supported beam with a uniform distributed load. It means we are going to use but M ultimate is equal to QL square all over 8 to have the maximum bending moment. Okay, so let me erase this, the remaining. So in order, we have our, we have been given P. So this cure here, cure L square, can be written, this formula can also be written as M ultimate is equal to what? To PL all over 8, knowing that P is equal to QL. Okay, so as we have been given the P ultimate or the sorry as we have been given the P ultimate already, we simply make the numerical application. We have our M ultimate, that's the maximum bending moment, is equal to what? Is equal to okay, we have not given the span of our beam. Let's just consider that our beam has a span of 4 meter. Okay, that's a data like in 4 meter span. Okay, this is an information lacking. So now we can apply our formula to have the maximum bending moment. So we'll simply have PL. So we have P ultimate, okay, 220 times what? Times the maximum, the span of our beam, which is 4 meter, okay, divided by what? By 8. Okay, so doing the numerical application, you have 220 divided by 4, multiplied by 4 instead, divided by 8. It will give us 160. Okay, so we'll have 160 kilonewton meter. Okay, this our M ultimate. In other words, that's our maximum bending moment, or the ultimate moment. Okay, so we can now write up here that our M ultimate is equal to 160 kilonewton meter. Okay, it's a moment, so it's in kilonewton meter. So now we have our M ultimate. What we lack now to have our ultimate moment, mu ultimate here, is just the design strength of our concrete. Okay, so let me erase this. We'll have the design strength of our concrete in order, following the Bael code. Okay, because we are designing here according to Bael, is simply equal to FC28. That's the characteristic strength of our concrete after 28 days. Okay, divided by gamma C. Okay, that's the safety factor for for our concrete. Okay. Okay, so according to Bael, we'll have 0.85, I forgot the 0.85, then FC28, the characteristic strength of our concrete after 28 days, divided by gamma C, which is the safety factor, or the coefficient of safety here. Okay, so doing the numerical application, the design strength of our concrete is equal to what? 0.85 times 25 megapascal divided by 1.5. Here the safety factor gamma C is equal to 1.5, but in other circumstances, this gamma C can also be equal to 1.15 when you consider the combination here under accidental accidental combination. For accidental combination, gamma C will be equal to 1.15, but for general cases, is equal, gamma C is equal to 1.5. Okay, so doing the punching, 0.85 times 25 divided by 1.5, we have 14.16. Okay, 14.16. That's 14.16. Okay, megapascal. That's the design strength. Okay, why? As you can realize here, you realize that the design strength is actually different from the characteristic strength that you actually choose for your concrete, okay, after 28 days, which is 14 megapascal a year. Okay, that's the design strength, the strength that you are going to use for your design. That's to show you how the safety factor actually majorate or reduce the strain of our concrete such a way that in the worst case scenario your structure will still withstand, because most of us here in Cameroon will know, for example, you will see somebody telling you that he wants to be a G+1 maybe for residential purposes. At the end of the day, he will turn that house up there to a snack bar, and then all that load, the people's gathering up there, the sound, the vibration all along, the structure will just collapse in case we don't have this safety factor. You see that the safety factor actually reduce the strain of your concrete such a way that you design with a small strain for the concrete, and at the end of the day your structure is strong enough to even where to even carry a load that was not actually predicted initially. Okay, that's the importance of the safety factor. So now you can say we have also the the design strength of our concrete 14.16. Okay, 14.16. Okay, megapascal. Now we are going to look for M ultimate. Now we look for M ultimate. M ultimate will be equal to what? That's the formula that has been written. We still like D. D here is equal to 0.9 H. H being the height of our beam. Okay, so D will be equal to 0.9 times 40 in centimeter. It is gonna give us 0.9 times 40 is gonna give us 36 centimeter. Okay, this D. So we can say we have all, but for a matter of unit, I will advise you to always convert everything in millimeter, okay, to have an easy equivalent, because this here is giving kilonewton meter, okay, and this one is in centimeter. For example, instead for me to convert them in meter, I would like to use that to convert all of them, but in this thing in millimeter. So this one convert in millimeter, you will be given to 160 times 10 to the power 3, first of all, to convert it in millimeter, times 10 again to the power 3 to convert it in Newton. Okay. Okay, so that's the conversion, is now in Newton millimeter. Okay, so now I'll go down, I will simply go down, and then I change now the design strength of my concrete, that is in Newton megapascal, that's Newton per millimeter, Newton per millimeter square. Okay, so I will just write 14. Let me write B first of all, the base of my beam here, that's 200. Okay, in millimeter, conversion in millimeter, this 36 will be 260. Okay, times the design strength of the concrete, which is 14 megapascal. You know that megapascal is in other words also equal to Newton per millimeter square. So is that's why I decide to convert everything in millimeter. Okay, another one can decide to keep them in centimeter or even in meter. So I do my numerical application, 160 times 10 to the power 160 times 10 to the power 6. Okay, divide by 200 times this, remember this is square here. Okay, 360 square. Okay, times 14.16. Okay, it's gonna give 0.43. Okay, it's gonna give us 0.43. Okay, U ultimate. Okay, so our U ultimate is 0.4355. So for 45, so let me just put it 0.44. Okay, our U ultimate here is like the ultimate moment reduced. It doesn't actually have a okay. So when you have this is a yeah, let's when you just have it, you just have now to compare it to a certain standard value. When you have your mu ultimate, now what you have is that you compare. If we have three scenario, if mu ultimate, okay, is less or equal or is less than 0.186, okay, then you are in pivot A. Okay, that's if your mu ultimate is less than 0.1 AC, you are in pivot A. And in this case, you can see that we are not more in pivot A. If your mu ultimate is greater than 0.186, okay, and less than 0.493, okay, you are in pivot B. Okay, in this scenario you are in pivot B. Okay, now this is the first, this is the second, and this is the third. If now your mu ultimate is greater than 0.493, then you are in pivot C. Here pivot C simply means that you have to imply change the you have to change the cross section, of your beam. Okay, so if your mu ultimate after calculation is greater than 0.493, you are in pivot C. In other words, you are being asked to change the cross section. That's go back and do the pre-dimensioning or the pre-dimensioning of your beam. Okay, I made video I've already did video on which we are actually showing how to do the pre-dimensioning, so you can just check in the video on all the video posts. You will see pre-dimensioning there. So or I will leave the title of the video there. So now we are looking at our mu ultimate here. We are 0.44. Okay, so we are in this second scenario, we are in pivot B here. Okay, you can see that we are in pivot B, since our mu ultimate is greater than what? Is greater than 0.186 and less than 0.4493. Okay, this first of all where we'll stop for this first part, and then in the next part of the design of the first concrete beam, we'll continue with the design of our beam. Okay, I'll first of all thank you for your attention, and then don't forget to like, comment, leave your question. If you have question, don't forget to leave them. Okay, and share the video to give me more power. Okay, it was Uult. Let's see you in the next video.